Oh, teacher, why do chemists like to eat avocado so much?
What? You mean the fruit avocado?
Yep.
I don't think chemists particularly like to eat avocado, so how did you get that impression?
Well, the other day I was walking past the other chemistry class and the teacher there kept talking about avocados.
Ah, and he talked about moles too, right?
Yes.
Okay, first, it wasn't avocado that you heard. It's
Huh?
Avogadro. Second, the teacher was teaching his class about the mole concept.
OMG. What's all that? Sounds hard already.
Like most things in chemistry, it might sound hard, but it's actually rather simple once you grasp the concept.
Well, okay then. Make it simple for me, teacher.
As always, first things first, the Avogadro number is simply a number, and that number is 6.02214076 times 10 to the power of 23. And because it's a number that is fixed, it is also called the Avogadro constant.
So I could simply say something like, I have the Avogadro constant amount of Singapore dollars in my bank.
Wow, then you'd be the richest person in the world by far.
Well, teacher, 6.022 times 10 to the power of 23 is a ridiculously large number. What in the world would warrant such a large number?
The number of atoms, of course. 6.022 times 10 to the power of 23 is the amount of carbon atoms in 12 grams of the carbon-12 element.
Oh my goodness, that's ridiculously a lot of atoms.
Well, atoms are so incredibly small. So yeah, it would take 6.022 times 10 to the power of 23 carbon atoms combined to make up 12 grams of the carbon-12 element.
Wow, okay.
New term to learn, the mole. In chemistry, the mole is a unit for the amount of a substance. Hence, if we say that we have 1 mole of the carbon-12 element on the weighing scale, then it means that there are exactly 6.022140076 times 10 to the power of 23 atoms on that weighing scale.
And given what you said earlier, you could also say that 1 mole of carbon-12 elements contains the Avogadro constant amount of carbon-12 atoms.
Correct.
And you could also say that the weighing scale would show 12 grams.
Correct again. So, as you can see, the Avogadro constant is the number of particles found in 1 mole of a substance.
I think I kind of get it.
Take note that you'd need to memorize this number, 6.022 times 10 to the power of 23.
Oh, okay.
Remember our previous lesson, we talked about the relative atomic mass of an element?
Yes. That's just the larger number of the element in the periodic table.
That's right. So on the scale, a hydrogen atom would have a mass of 1 unit, and an oxygen atom would have a mass of 16 units. Remember?
Yes.
Okay, so 1 mole of hydrogen would contain the Avogadro constant amount of hydrogen atoms, and if placed on a weighing scale, that scale would show 1 gram. Likewise, 1 mole of oxygen would contain the Avogadro constant amount of oxygen atoms, and if placed on a weighing scale, that scale would show 16 grams.
But teacher, that is weird. How can 1 gram of hydrogen contains the same amount of atoms as compared to 60 grams of oxygen?
Well, The way to think about it is as such. Hydrogen atoms have much lesser mass as compared to oxygen atoms. Thus, to create a count of 6.022 times 10 to the power of 23 atoms, only 1 gram of hydrogen is needed, whereas for oxygen, 16 grams is needed.
And for carbon, 12 grams is needed.
Correct!
Okay, I think I get it.
Great. Now, let me extend this concept and introduce to you Avogadro's law.